8041. Why does the smoothness of operation of an engine increase with a greater number of cylinders? A. The power impulses are spaced closer together. B. The power impulses are spaced farther apart. C. The engine has larger counterbalance weights. The correct answer is A. The smoothness of operation in an engine increases with a greater number of cylinders because the power impulses are spaced closer together. In a multi-cylinder engine, each cylinder fires at a different point in the engine's rotation, creating power impulses that are distributed more evenly throughout the crankshaft rotation. With a greater number of cylinders, the time between each power impulse decreases, resulting in a more continuous and balanced power delivery. This helps to reduce vibration and provide smoother engine operation. In contrast, an engine with fewer cylinders has power impulses that are spaced farther apart, resulting in less consistent power delivery and potentially causing noticeable vibration or unevenness in engine operation. 8042. Compression ratio is the ratio between the A. Piston travel on the compression stroke and on the intake stroke. B. Combustion chamber pressure on the combustion stroke and on the exhaust stroke. C. Cylinder volume with piston at bottom dead center and at top dead center. The correct answer is C. Compression ratio is a measurement that determines the relative change in volume between the cylinder of an internal combustion engine when the piston is at bottom dead center, BDC, and top dead center, TDC. It is calculated by dividing the cylinder volume at BDC by the cylinder volume at TDC. The compression ratio is an important factor in determining the engine's efficiency, power output, and combustion characteristics. 8043. If the crankshaft runout readings on the dial indicator are plus 0.002 inch and minus 0.003 inch, the runout is A. 0.05 inch, B. plus 0.001 inch, C. minus 0.001 inch. The correct answer is A. Crankshaft runout is the total difference between the highest positive and lowest negative dial indicator readings. A reading of plus 0.002 inch and minus 0.003 inch gives 0.005 inch total runout. 8044. 1. Cast iron piston rings may be used in chrome-plated cylinders. 2. Chrome-plated rings may be used in plain steel cylinders. Regarding the above statements, A. Only one is true. B. Neither 1 nor 2 is true. C. Both 1 and 2 are true. The correct answer is C. Both statements are true and correct. 1. Cast iron piston rings can indeed be used in chrome-plated cylinders. Cast iron rings are commonly used in engine applications and can provide good sealing and durability. Chrome-plated cylinders offer enhanced wear resistance and reduced friction, and the combination of cast iron rings and chrome-plated cylinders can provide reliable performance. 2. Chrome-plated rings can also be used in plain steel cylinders. Chrome-plated rings have a layer of chrome applied to their outer surface, which provides increased hardness and wear resistance. They can be used in plain steel cylinders to improve the durability and performance of the piston ring or cylinder interface. 8045. How is proper end gap clearance on new piston rings assured during the overhaul of an engine? A. By accurately measuring and matching the outside diameter of the rings with the inside diameter of the cylinders. B. Combustion chamber pressure on the combustion stroke and on the exhaust stroke. C. Cylinder volume with piston at bottom dead center and at top dead center. The correct answer is C. Place the piston ring inside the cylinder and push it up with the top of the piston until it is square in the cylinder bore and parallel to the cylinder flange. This will allow you to measure the end gap in the piston rings. With the ring in this configuration, use a feeler gauge to assess the distance between its two ends.